ClearPoint Ag, that's my consulting company. I work with, it's myself and Nicole Glenn. She's gonna finish her tenure out as a Beck's agronomist for the southern region, and she'll be on board full time. And somehow I created a consulting company from nothing, and now the good Lord's blessed me to manage about 90,000 acres out of this, and that's wheat, corn, and beans. And you're thinking, is that too much? The answer to that, yes, that is too much. So we're bringing her on, but we're kind of getting out of the scouting way of it and consulting, which is just the farms, crop planting, meetings like we're doing now. I have these one-on-ones with growers all the time, and it's a lot of fun to do. So there's one thing I want to leave this quote off. I did this last meeting that I was at. I like to read a lot. I like old English literature. I also like John Steinbeck and Hemingway as well, but that doesn't matter. This is the Oscar Wilde quote. The truth is rarely pure and never simple. That's from The Importance of Being Earnest, his play. And you probably don't come to a lot of ag meetings where you talk about Oscar Wilde, but I think that has everything to do with the things that we are learning and the paths that we are going on. It's the things that we hold true that prevent us from going further sometimes. It's what we think we know. What's the quote? There's a quote, it's a Mark Twain quote, it's what you know for sure that ain't so, or something. It's something like that. It's a terrible paraphrase, but it's a Mark Twain quote rather. So, what are we doing at ClearPoint? As I said, we're managing 75 to 90,000 acres. And because I'm terrible at business, I'm able to dwindle that down to people who are focused on these tenants. I can't do my job focused only on money. I can't do it. I care too much about this ground the good Lord has blessed us to be stewards over. I care too much for that, because it's all in His will what I'm able to do every day, and all glory to Him for that. So the people that I'm working with, and I'll have probably between wheat and corn, 20 to 30,000 acres this way this year. It's going to be reducing synthetic inputs, increasing return on investment, creating healthy soils through healthy plants. And I believe with everything, that's going to create a healthy mind, body, and spirit attitude towards agriculture. I firmly believe that. I spend nights in prayer about this. I mean, I firmly believe that this creation is divine. When you start looking at this thing through a lens and through a microscope, you're never going to be able to understand it. We're going to come up, and Dave and I have talked about this, we're going to come up with test after test after test after test, and we're still never going to understand it, because it's divine. We can work with it, but we're never going to fully understand it. And I think that's a beautiful thing. I think that's a beautiful concept. I do think we've done damage to it. I think we do owe a penance, and I think going forth, and Philip coined this word when he was talking, I don't even know if he remembers this. He said it's a restoration. It is a restorative process. It is a restorative process what we're going on. So I mean, I don't have a long presentation right here to show you some things that I'm working on. Who was talking about data? Who's that? Mark talking about data? My guys are terrible at data. Terrible. I mean, like the worst. They're like, if you're not here in 37 seconds, we're cutting it. And that's what happens. So I've got a few yield maps I can show y'all, and some on the side, but the rest is anecdotal and conversations. So where do we start? First, you gotta know your context. What's the context you're working around? What is it you're trying to achieve? You know, these are the conversations I have with the growers I'm working with. What is our context? You know, is your context anhydrous? Okay, nobody's saying park the applicator. Let's try to learn how to use that more efficiently. Let's try to not make it such a detriment. Philip and I visited Brandon Roby, who's a big customer of Philip's, and Philip, you can't tell, you're gonna keep that in-house, it's a trade secret right now.
You go ahead, you tell.
We're welding on his vapor tubes on the back. We're putting a 20, because about one tank of his anhydrous is running 25 acres. He's got a 25 acre full tank of electric pump. We're gonna inject, was it a gallon? It was a gallon. Gallon of vitamin tear an acre behind his applicator. We could have a long conversation, but I'm not gonna bog it down while we're all doing that. I'm just saying, what is our context? Work around that. That's what we did. We didn't say go buy an applicator. Let's look at this applicator and how can we work with that? How can we work with it? What are we doing well? What's something y'all feel like you're doing well on your farm right now? That's not a good answer. Somebody's got to be doing one thing good. Nothing? David, Hula, you doing some good things good on your farm.
Walking in the field is one thing, spending time observing.
That's it, right there. I meant to bring that point last week, but my ADHD rambles too bad, and I will not medicate myself. I'll just lean into it. So, anyhow, I want to go back to that, what you just said. What you said. The biggest difference I've ever made in a farm's operation is not going out into a field to search for a recommendation. It's going out into the field, and y'all can think I'm crazy if you want to. I've been called that more than once. It is stopping, closing my eyes, listening, feeling, and just taking the time to just feel the changes in that field. Y'all may think that's crazy, but if you've never done it, I promise you'll change your life. Because every field's different. We're all at a different frequency. So, I'm just saying that's something to try. All right, so we know we're doing well. What are things we can do better? You know, we've had a lot of talk today on things we're working on. We've talked about nitrate, we've talked about trace minerals, we've talked about herbicides. So knowing the information that we've gathered today, how do we utilize that? If there's utility in that, all glory to God for that. I'm here for him. So, but if there's utility in anything that I've said today that you can take that and think you can do something better with, then let's use that. Because this is science. This isn't the science that's bought and paid for that we've been sold. This is the science that you've got to read after phytopathology textbooks after phytopathology textbooks to find the answer, because they're out there. Those books are out there. And they're a lot of fun to read once you get to read them. Can we say our system that we're working in reflects our best? Not the best version of us, what we're doing. Or it's the most efficient version of us. That's something just to ponder on. And you got to forget what we think we know. I tell every single person I meet, I am not in the knowing business, I'm in the learning business. There is plenty of bad people in agriculture for me to add to that list. There's plenty of them. There's a lot of great folk that work in this business too. But there's a lot of people who say, who've met Philip Davis, who've met Josh Davis, and they'll walk out, oh, that can't work. Ask them why, they won't, they just can't. There's too many people like that. We need more than people in here. We need more the can-do guys in here. So forget what we think we know. I talked to some people about this last night. I've got a first edition of this book. I don't just sit at home and read. I know it's what it's getting sound like, but it's not the only thing that I do. So it's the Farmer's Everyday Book, Reverend John Blake. I was reading Arden Anderson's book. His quote was in there. I was like, well, I got to find this book. So it came in the mail, and magically, it's like that thick. It looks like a Bible. The third page I turned to had this information in there. So in the 1820s to 1840s, this book was published in 1851 by the Reverend John Blake. He was going through accounting for yield, which I thought was neat anyway. I thought that was pretty awesome that somebody had the wherewithal to take account of that. Because the only reason you was raising corn back in those days was for your animals. That's what you raised. But y'all see those yields up there? Can y'all read those or no? Can y'all read those in the back?
Yeah.
Do y'all understand that is not even close to the same plant that we raise now? That's a land-raised corn. That is a land-raised, open-pollinated corn. And 190 bushels in 1840. Let that ruminate inside of you and think, how far have we come or how far we have not come. I don't know who had 190 bushel baskets back then either, but somebody did because they counted all of them. But 190 bushels in 1840. So have we come far? That's what I got. I mean, I'm not going to say I was like...
Society knows. People have.
People have. Have we come far in terms of yield? I'm not saying this is average, first off. This is not average.
Yep.
But this gentleman here, Pratt Master, in that same book, it was a 172, it was a 174, and in 1826 it was a 176. So he went up, and their agronomic advice was ample amounts of manure. That was it. But it's pretty neat in there. It talks about worms. It talks about things living inside the earth. I mean, it comprehends the entirety of it without the nuance, I guess is how that looks. So, Josh, you might have talked on this. We're doing a meeting February 21st, and I have to miss James White. James White took this work over from Christine Jones, rethinking nutrition delivery. Why is that there? Because this is how this guy made his corn. Is anybody familiar with that? Who's seen that before? No? Somebody seen that before? Raise your hand. One. Josh, I know you've seen that. Philip, I know you've seen that. Mr. Hill, I'm sure you've seen that. This is a rhizophagy cycle. This is how God designed this system. I'm going to give you the world's worst version of this in about 17 seconds. Okay? So plants are pretty much farming microbes. But it's mutualistic and it's transactional. The microbes, mycorrhizae included, have something the plants want, the plants have something the microbes want. So as you can see, the plants, we talked about reactive oxygen species in the break a while ago. We talked about, keep the thought. Because somebody's got to keep the thought in my head or I'll lose it. So plants take in live microbes via root tip and strip off the cell wall to do so. It does so by reactive oxygen species known as superoxide dismutase. Guess what happens to be a cofactor of superoxide dismutase? Could it be manganese that we're shutting down from Roundup? That's exactly what it is. It's 100% what it is. So these microbes are ejected from the root hair. It's a self-fulfilling prophecy right here. I'm sorry, keeping it going on and on. So these nuclei, they have bacterial metabolites in them in the form of nutrition that a plant has to do nothing but take in and utilize. Your plant is at an energy gain because it has to do no metabolic processing of these nutrients. They are in the bacterial cells. So this plant just farms them out, spits them out of the root hair, soaks them back into the root tips and the root cap there. And then when they're done partying, they go back out again, recharge in the rhizosphere, and play that process out in perpetuity. Now this part's important right here. Right there. Corn don't do that. Bean, do you see that, what that says? It says all plants. It's the third time I've spoken in absolutes today, so I'm try not to do. But it happens in all plants. Right here. Right there. See that bottom where we talked about chelating herbicides? Remember the last presentation? Chelating herbicides? This is, Dr. James White hypothesized in one, I've heard him say this once, that you can get 105% of your nutrition this way. So why is 105% different? What is that saying? If we think about that, what is that saying? Is that saying that we can have luxury consumption for free?
Yeah.
It's what it's saying. That's exactly what it's saying. So if we can do this with 105%, why do we have such an emotional relationship with our P and K? Now, I'm not sitting here telling you plants don't need food. I'm not telling you it's going to happen immediately. There is some remediation and restoration that has to be done. But I'm telling you, this is what we need to get to, fellas. If we're going to continue farming, and we're going to have a place for our children to come home to and feel good about, we need to be dependent on this for nutrition delivery. I know it's a lot to look at. Is there any questions about that? Oh, sorry, yeah. The driver of this whole thing. What's our plants trying to do? What do our plants want to do? They want photon energy.
Reproduce.
Reproduce. Well, we got to collect to get there, though. What do we got to stitch together? Right? We know what that is, correct? Photosynthesis. This to the point. If you could sell sunshine in a jug. Y'all can read that right there. The constituents. Those two right there are unavailable because they're in the what form we talked about? Reduced form. Sorry. We farm in a highly oxidized environment which reduces those. So if we increase photosynthesis, we can increase the plant's immune system. How do we do that? How do we do that? Through root exudates. Now, I don't know why people in science make up words, but they do, to make the rest of us feel dumb, I guess. That's part of it. You know, I fall prey to that a lot. Oxidates, just a big word for sugars and proteins, acids, you know, starches, carbohydrates, things of that nature. So, I think, you know, to know where I'm headed, there we go. So, what does this matter? If 100% is a greenhouse with CO2 pumped into it, that's it, that's sufficient, that's what you can get. Where do you think the studies show that we are in production agriculture and corn? There is a difference between the C3 and C4 plants for the way that the relationship with the ribosomes are with oxygen and corn and beans, but I don't guess that really matters because they're still floating. I'm just rambling. So, what rate do y'all think we're photosynthesizing?
Do what?
What rate do you think that our plants have the what's our photosynthetic capacity right now?
100%.
15. 15, I wish.
Compared to what?
100%, compared to a greenhouse with CO2 pumped into it.
So there you go.
Yeah.
The plant by itself is at 100%.
Pardon?
Plant by itself is at 100%.
100% of it by itself?
Yeah.
A plant in nature would be 100% by itself. I'd agree with you on that 100%. We're getting all kinds of 100% now.
Yeah.
But in production agriculture, we're probably looking at around 15%. So that's where we're getting the refractometers. And that's why refractometers are important. Whoever your agronomist is, you can buy a great one off Hannah Instruments for probably, I think the last one I bought, it was less than $500. Anybody, you bought one recently?
Not recently.
Josh, have you?
No.
I can't remember what they are. The digital ones are the way to go. They really are. But anyhow, the good thing about refractometers, let's say you make an application. Let's say you go out to your field and you make an application of Roundup and Dual, whatever, you spray Roundup and Dual. 15 minutes later, you test that, you'll see a reaction. Your Brix levels will drop. It will let you know what you're doing pretty quick. It's measuring the mineral solids of your plant content, pretty much the rate of photosynthesis. So I was talking about earlier in our last conversation about Brix and plant health. Dr. Tom Dykstra is the one who come up with the chart. If we can, 5%, we're hanging on for life, and that's where most of us are right now. You go out in the cornfield, it's going to be 5.5%. Not those fields we talked about with you, David. Those are extraordinary and just amazing accomplishments. But the highest you were there that day in Ohio County, we had a field at 17, and I can keep them at 12. Problem with doing that on GMO, can anybody remember what the problem was with GMO and Roundup? Anybody remember what the problem was with that? Anybody remember those two I was talking about? Told you I'd get somewhere finally with my thoughts today. And they're all circling the wagon now. Those two. Well, mainly manganese, but iron too, but iron's reduced. Manganese is the first step of photosynthesis. We have to split that water. We have to get that energy out of that water. We have to do that. And if we're chelating that, if the first step is reduced to deficiency, would it be intellectually honest to think that we can convince ourselves that we can go forward with a healthy planet? I mean, just an honest question. Does it make sense if we reduce the efficiency of step 1? Should I be better at step 5? I mean, I think that's a no, isn't it?
Correct.
Yeah, I mean, that's what we've got to get to. And these are the constituents of, I should probably put sulfur in there with that, or boron in there with that, but these are constituents of that. The problem with this one is, it takes 3 moles of water to fix 1 mole of nitrate in that. So let's go back to that. We start chelating this here. You see where I'm getting with this? You affect one step, you affect them all. So if we continue with Roundup in the system, no. If you continue with GMO in the system, please keep manganese applications in every pass over your field. I'd probably go for zinc and iron as well.
How much?
That's one of those funny questions there.
I usually do 4 hours.
It's the functionality, it's percent, and it's the form. Because if someone does not have, if you pull up your phone and look up manganese right now, because I had a conversation with a group that I respect a lot, and they told me they had the best manganese, guess what the active ingredient was? Manganese oxide. Remember what I said about oxidized form of manganese?
Oxide is a bad word, that's a negative word.
Yeah, we don't want manganese oxide, we don't want iron oxide. Those are biologically inactive, biologically unavailable. So I do have a meeting with a chemical engineer named Graham Towerton to help me figure out some of that stuff. Because it's above my pay grade. But as Josh said, it's not as much about rate as it is functioning utility. And I do agree with him on that, because we're metabolic shortcutting there. I should have put the chart in there. I can share it with you or text it to whoever, where it shows you pounds of applied with certain forms equals pounds per acre. So here's our actionable plan. This is what we're working on this year and last year. And I hope this keeps continuing. It's adding carbon to the system. Vitamin Terra, combos, whatever you're talking about. Our plants are 45% carbon by dry matter basis. Do we give plants 45% of our budget in carbon? I'm not saying necessarily have to, but do we? We don't. We don't. Number 2 is probably the big one. I think Josh would probably agree with me on that, not speaking for you. But less reliance on large soluble dumps of nutrition. Because if we do that, we get less of that. Large soluble dumps of nutrition, shutting that down. We're not getting to where we want to go. Number 3, managing nitrogen. I shared with you all my nitrogen plans. Everybody write that one down. As long as you don't tell nobody in Kentucky, Tennessee to give it for free. So that's going to be Vitamin Terra, Carbos, Molly B, sulfur. That is my nitrogen efficiency plan. Then the rates for me, I can't speak for Philip and Josh. In my estimation, the rates change as my nitrogen rates change. Because we're looking at percents. We're looking at percents. New systems of testing. Tissue testing is good. It is good. It's not good for managing our oxidized nutrients, copper, cobalt, iron, manganese. We need to look at SAP for that. I think with what we're doing with SAP, we can get predictive. I have the distinct privilege to work with Waters Lab to develop the SAP testing protocol for them around our area. I'm gonna have about 20 fields tested weekly. So if you're SAP testing, have it done by 8 in the morning. Have it done by 8 o'clock in the morning if you're SAP testing. That's some transpiration races. Have it done by 8 o'clock in the morning. But what I'm gonna do is send ours to Nova Lab and send ours to Waters Lab. But what we want on our SAP test, this might blow you away, if we see a high nitrate number in our SAP, guess what that means? That means we're low on a cofactor, doesn't it? We want a big total nitrogen number. We won't want a nitrate number, ammonia number. Yes, sir.
So you say 8 o'clock for the SAP test, but doing a Rick's test is 2 or 3 in the afternoon.
Because of sun.
For the maximum.
Mm-hmm. You're right, because you want maximum sunlight on that. I usually pull my bricks around 1. If I'm sweating, I'm pulling my bricks. You're right. And that is the problem. I'm glad you said that. I was going to get into that. But what I like about the SAP test is that there's a total nitrogen number on there. You can get a bricks number on your SAP test, but consider the time of day that you're taking it. Consider the time of day that you're taking it on your SAP
Right,
test.
if I take it at 8 o'clock in the morning, it's a 3.
But if we're doing our job, we can hold that on a 24-hour photo period. That is the one thought. And that's what we had it at 12.1 last year on that non-GMO. Oh man, it was so much fun. It's so much fun to see a field like that. All right, result driven. That's blurry. Philip, you remember Chad Elkins' planter? How terrible it was?
Yes.
Okay. Remember you told him 200 bushel, he could make no more, and that was the day the corn was planted before it even emerged?
Yeah.
This field was they both averaged 197. I don't know why that doesn't say that. This field is conventional methodologies. at probably $100, $80 an acre more than this field. Done with a program from Genesis Ag. Now, is the yield difference? No. Philip told the man, Philip, would you tell him about the planter, the joys we have with this bent planter?
I don't want to go there.
Okay. There was air pockets under every seat, no matter how you adjusted it. Depth, we adjusted on the thing for an afternoon. Depth would go anywhere from 1 to 3. There's nothing you could do. We finally got it dialed in a little better, but anyway. This is the field they'll tell you at the co-op you can't farm this way. And I've got the soil sample sitting on my computer over there, whatever good they are, after this harvest was made. So we didn't mind any soils either. This field made the same as that field, $80 an acre less. This year we're marrying that system to non-GMO, we're gonna be $125 an acre less. And I fully expect, now that he's traded planters, and doing some things different, that our yield will increase. 100% of it, I expect that. I mean, our capacity last year was his planter. There's no ifs, ands, or buts. That was the capacity, I mean, that was our yield capacity, or yield limiting factor. Mineral-driven defense. Did I talk to anybody about my iron program that I did on this guy? They said they told Chad Porter to destroy these fields. Phillips in these fields as well. These are the same farms. The seed company come out, destroy your fields, you have a crown rot, there's absolutely nothing you can do. You can't fix it, fungicides don't work. And I agree with that. Fungicides aren't gonna fix crown rot. I totally agree with that. But, as I've referenced before in the phytopathology textbook, Mineral Nutrition of Plant Diseases, please go buy that. Everybody go buy that. Treated with iron, copper, manganese, and zinc. Y'all see the yield difference? This is what you can't do. Now, I failed because we should have done both farms. Y'all see the yield difference? The same farm. You know how much that application cost? It was less than $15. It was less than $15. Was that money well spent? I mean, maybe he should have took insurance on all of it. I don't know. But from where I stand in the game that I'm playing, that I take very seriously, this is what I'm focused on. This is what I'm focused on. These are the things that we're able to do if we farm within the system. You know, I think where we're going to fall short, is we're all good people, we have these relationships, and we want to buy from the guys we're going to buy for it. I get that. And when we try to meld these two things together, then I think we don't get, we don't see the full benefit which trying to marry the two systems together. I don't think an amalgam's out there for us. I could be wrong. I mean, I know there's things we can implement like nitrogen. What I'm talking about is there's no sense in spreading 250 pounds of nitrogen out there, 200 pounds of DAP, 200 pounds of potash, and then trying to do something. Let's just be reductionist. Let's take a reductionist strategy towards this. Same farm, same variety, different practices. Took these pictures right next to each other. Army worms are coming, they're gonna take over the world. That's what it was this summer. Everybody's gonna die. Army worms are coming. This field, fungicide, insecticide. The rest of the field, trace minerals and carbon. Can y'all see the difference just looking at that? And it never rained again after that day, so that's a joy. But it never rained after that day. So, but can you see the visual differences there? The army worms never came into this field with no insecticide. They were all around, they were there, but they were never in this field. They were never in this field. We raised the frequency of that. They're never in that field. They can't digest. Their digestive tract will not allow them to eat those plants. They can't metabolize it. They will die. This is the same guy. Did I tell y'all about the wheat that he had? Did I tell y'all about the wheat that he had? So his name's Matthew Carter there. He farms there around home. About the head scab, I already tell that story? Yeah. Well, don't let me repeat myself. So this is pretty much my last slide here. And this is it. Dare to be great, dare to be different, because in the end, only mediocrity escapes criticism. That's it. And I'm gonna live by that. I'm gonna die by that. Because I believe that. Fellas, they're gonna talk about you anyway. Might as well give them something to talk about. So, I appreciate y'all having me. And if y'all wanna get a hold of me, I don't have a website because it's just me, but I'm on Facebook or whatever, ClearPoint Ag, and I'll sit down and talk to agronomy anybody, any day of the week anybody wants to. So, anybody got any questions?
So those differences you showed in the fields there,
That one?
is that a one spray with the?
I did it on, yes, I did that one on a V3, and just at V10, we come back and added some more. But it was already passed, it already outgrown at that point.
Is it something you think if you could build those nutrients in the soil, would that do it? Or do you think it needs to be a foliar applied deal to get in the plant?
Great question. Iron and manganese in the soil exist in an oxidized form, and until we get reduced environments, like you probably have to talk about cover crops. If you had cover crops, you probably could get reduced iron and manganese in that system. You could probably do that. But if you're in any tillage whatsoever using nitrate or muriate of potash, you're gonna have to rely on foliar. But just make sure, if it says manganese oxide, or if it says iron oxide, do not buy it. Say thank you, I appreciate it, I'll get priced somewhere else. Just be sure of that. If it says oxide, don't use it.
A couple times it's been mentioned manure. Do you get the same results adding more biology to manure applied fields? Is there benefit in doing that, or?
I would say you get more results. I would lean on Josh or Phillip, but what I've seen on inoculating system with manure, especially on the dairy guys that I've worked with, I can show you straight to the line on yield maps. I'm just not forward thinking enough to this moment, thought I'd need that yield map to show. But no, I've seen more. Phillip or Josh, y'all care to touch on that?
So I agree with that. The manure, you think back to how we farmed before synthetics were available, and even some of the older pictures Josh showed up there, how much healthier the soil was. We're killing ourselves to apply this synthetic. If we could get a more organic form of fertilizer or carbon, I think Josh alluded yesterday in a conversation, some passing through the rumen of a cattle or a hog or any of that is providing bacteria that is hard to replicate in any form or fashion.
Absolutely.
Do you manage liquid manure different than dry pack manure, liquid bottom manure?
The good thing about liquid manure is, Phillip and I are working with a guy in Bowling Green. We're pouring, don't let me mess the rates up, 100 gallons per million gallons
Yes.
of vitamin terra in there with that. Stabilize that ammonia, reduce your smell, really maintain the integrity of those nutrients in the form it's not going to leach off. You're giving them something to hold on to. As we talked about earlier, you're going to have an anion exchange capacity and a cation. The cation exchange capacity in this product is probably north of 300. So you have a lot of exchange sites for those cations. You're also going to have that anion for the negative charge. So you're going to have that form to hold on to. They're not going to be near as leachable. And that is a beautiful concept and a great question.
One of the things too, Josh, Josh Davis spoke of it earlier when he was talking about the vitamin, and that's our morphos, and we're probably going to rename that because everyone thinks it's just phosphorus solubilizing bacteria, but we're also finding it's doing the potassium solubilizing as well. My guys that are heavy manure spreaders out in the high plains and the dairies and what have you, that's become real essential to them, to getting that to break down. In Tennessee, where guys are doing poultry litter, they're seeing a tremendous benefit out of it there by having in the program to make those manures more available.
With people composting, do you see a fit with that in compost too, as a composting additive?
What was that, Josh?
If you're composting, if people are composting, could you add that as a compost additive in there with that?
I would just put it on after I spread the compost.
Okay, because I've got to address that question Thursday to me. Great time to ask now. Well, I appreciate your time. I got almost 11-hour drive back, so I got to get on the road. Thank y'all.
Thank you.